Hello everybody, today we're going to be looking at solving using square roots and radical review. We need to get some review with some radicals as well. So, when we're simplifying for radicals for all a and b such that a and b are real numbers, all right, that's what this means. They're elements of the real number set, and a times b is real, then the square root of a times b is the square root of a times the square root of b. And the square root of a divided by the square root of b is the square root of a divided by the square root of b. All right. So what this will do for us is if I have the square root of 40, for example, I don't want to leave it as 40 because I know that I can break it up into the square root of 4 and the square root of 10. And I know the square root of 4 is 2, so the square root of 40 is 2 square roots of 10. I have the square root of 54. That's the square root of 9 times the square root of 6. Square root of 9 is 3. This is 3 radical 6. 2 times the square root of 75. I want to split these radicals up into something I know and something I don't. I know the square root of 25, and I don't know the square root of 3. The square root of 25 is 5. So now I have 2 times 5 is 10, and then square roots of 3. The square root of 6 times the square root of 8. Now you could simplify first. The square root of 8 is 2 square roots of 2. You can double check that yourself. Or you could do square root of 48. If you do square root of 48, you need to split 48 up into square root of 16, square root of 3. Square root of 16 is 4. So this is 4 times the square root of 3. Okay. Next, we have 3 root 10 times 2 root 5. Nothing I can simplify right away. So that'll be 6 root 50. And 50 is the square root of 25 and the square root of 2. The square root of 25 is 5 times 6 is 30 times the square root of 2. All right, if I have a fraction and I can go ahead and start simplifying it, like I can just do the square root of the top and the bottom. So I have 5 over 2 here. Alternatively, I could simplify first. So like 2 over 2 is 1, and the square root of 1 is 1. So I can ignore this whole term. Now I have root 5 over root 8. You might remember, we don't leave radicals in the denominator of a fraction. So what we have to do is called rationalize the denominator. Now, I'm going to simplify the denominator first. Radical 5 over, that's square root of 4, square root of 2, so 2 roots of 2. Now to rationalize the denominator, I multiply the top and bottom by the same number, and I'm going to do the square root of 2. That'll give me radical 10 on top over 2 times the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2, and 2 times 2 is 4. So square root of 10 over 4 is my answer. I can do the same thing here. The square root of 12, I'm going to break up into radical 4 and radical 3. Radical 4 is 2, so 8 over 2 radical 3, and then I'm going to multiply by radical 3 on top and bottom. So 8 radical 3 over 6. Okay. We also want to be able to solve equations using square roots, okay? So, what we want to do is we can only do this when we have just a quadratic term and a number. We can't do it if we have a linear term. We want to get the thing that is being squared isolated. So we want to get the thing that is being squared, the quadratic term, all by itself. So for example, x squared, that's isolated. So now I'm going to take the square root of both sides. And x will equal the plus or minus square root of 49. So x equals plus or minus 7. But wait, Mr. Toro, why did this plus or minus come out of nowhere? I understand that 7 squared and negative 7 squared are both 49, so I get why that's an answer. But why did we get that, but we didn't get them up above? Why does the plus or minus only happen when we're solving an equation? And it's because you've been told a lie. I'm going to explain this really quick. The square root of x squared, you've been told equals x, but that's not true. The square root of x squared is always positive. And things that are always positive, we're looking at the absolute value of that number. So this is actually true. What we're really saying is that the absolute value of x equals, in this case, 7. Therefore, the distance that number is from 0 is 7, so x could either be positive or negative 7. That's where that's coming from. We usually just skip the absolute value step. Okay, so x squared equals 40. Well, again, it's isolated already, so I can square root both sides, and I get x equals plus or minus radical 40. 4, 10, square root of 4 is 2. X equals plus or minus 2 radical 10. In this next example, I have to add the 5 over. I want to isolate the quadratic term, so I'm going to add the 5. 3x squared equals 24. I got to get the x squared by itself, so I'm going to divide by 3. X squared equals 8. Now I can square root both sides. X equals plus or minus radical 8, which is radical 4 and radical 2, and radical 4 is 2. So x equals plus or minus 2 radical 2. All right. In this example right here, I have 2x squared over 3 plus 2x squared equals 4. I'm going to start by multiplying the whole equation by 3 to clear the fraction. So 2x squared plus 6x squared equals 12. Those strategies from Algebra 1 still work. 8x squared equals 12. I'm going to divide both sides by 8. So x squared equals 12 over 8. I'm going to replace 12 over 8 with what? 3 over 2. If you can simplify your fraction first, it's not a bad idea. It's just going to make it easier when you then simplify the radical. I'm going to take the square root of both sides, and x will equal plus or minus radical 3 over 2, which I'm just going to replace with radical 3 over radical 2. I want to get rid of that radical 2 in the bottom, so I'm going to multiply by radical 2 on top and bottom. And that's plus or minus radical 6 over 2. All right. These examples here with the parentheses are a little bit different. I have 3 times x minus 2 squared equals 27. So I'm going to divide by 3 to isolate this set of parentheses. You cannot distribute the 3 in because then you're doing multiplication before this exponent. So x minus 2 squared equals 9. Now I'm going to square root both sides. I have something squared equals 9. So x minus 2 will equal plus or minus 3. Now I'm going to split this up into 2 equations. X minus 2 equals plus 3. And x minus 2 equals negative 3. Add the 2 over, x equals 5. Add the 2 over, x equals negative 1. Let's try that one more time. So I can't have the negative 2 in front, I can't distribute that in, so I'm going to divide it out. X plus 6 squared would equal 20 then. I take the square root of both sides. X plus 6 would equal plus or minus radical 20, which is radical 4 and radical 5. Radical 4 is 2. So x plus 6 equals plus or minus 2 radical 5. Well, I subtract 6 from both sides, and x would equal 6, negative 6, plus or minus radical 5. Make sure you don't, so I'm going to subtract 6 from both sides. And a really common mistake here is to do 2 minus 6 and say it's negative 4. But that's not true. You're subtracting and adding before you're multiplying there. So I have to say that x equals negative 6 plus or minus 2 radical 5. And that's my solution. Be sure to follow your order of operations carefully. All right, thanks guys, and have a good one.